In this video, I wish to discuss some of the major issues that are bothering me. First of all, why did the Big Bang happen at that particular time? Another is the Baryon asymmetry problem. It is that after the Big Bang, instead of particles and antiparticles having to be created at the same amount, why did the particles become more numerous? Another is why particles can exhibit both particle and wave properties at the same time. Let us see how can I explain it all with the help of this simple idea. From this idea, we can get answers to a lot of questions that we are looking for like this. If we place this idea into the space technology, we can achieve a very huge velocity to the spaceships. Our universe is a storehouse of wonders. This vast universe of ours, the tiny particles within it, their fundamental features, the very large stars, and their formation processes, all amaze us a lot. And the functioning of our universe, the stars, their planets, their subplanets, the atoms, the particles within it, and their features are all wonderful. We will be amazed again when we realize that all of these things are the result of a process that we called the Big Bang. There is only one reason for all these miraculous phenomena. It also provides answers to many of the questions we seek. Let us start with the first problem. Why did the Big Bang happen at that particular time? We know that the Big Bang singularity had the energy to encompass the entire universe we see today. If more than a certain amount of energy is concentrated in one place, it is possible for to be born a star over there. We are not talking about its causes here. Then even though the energy contained in the whole universe was concentrated in one place, why did the Big Bang not happen earlier? Or why didn't the Big Bang happen a little bit later? So that it can store some more energy into the singularity. In any case, I do not believe that the singularity was formed by the intervention of God and that the Big Bang happened. I understand energy and space as the only two fundamental building blocks of the universe. All other phenomena we see in the universe are the result of interactions between them. To understand the universe, we must first understand how energy exists in space. Space is just as important as energy. Space is essential for energy to stay. Therefore, a certain amount of energy will be kept in influence on a certain amount of space proportional to it. But if the situation is like this, the universe will be in a balanced state. If the primordial universe were in such a state of equilibrium, not even the Big Bang singularity would have formed. So there must be an unbalanced situation in the primordial universe. That's why, in the primordial universe, the amount of space or energy must have been greater than any one of these two. If the amount of space is a little more or less, it will create an imbalance there. It was this imbalance that led to the formation of the Big Bang singularity. This is one of the main reasons for the subsequent Big Bang. Already we know many other reasons to encourage the Big Bang to happen. Like the density, pressure, temperature, and many other situations in that period. Here we are looking for the reason to happen the Big Bang at that particular time. So the interaction between space-time and energy is important for this situation. So, it was this imbalance that created the favorable conditions for the Big Bang to happen at that particular time. The Big Bang happened only when the imbalance between energy and space reached a certain ratio. All these situations are well described in my book, The Key to the Secrets of the Universe. You can see the evolution of the universe from the primordial stage until the destiny of the expansion of the universe in my book. There you can see a lot of new ideas on the expansion of the universe and about gravitational interaction. I am explaining there how the expansion of the universe is undergoing another Big Bang. You can find the link to the book in the description box. Now we will see why did the particles become more numerous. We generally call this Baryon asymmetry problem. After the Big Bang, the particles were created in pairs, particles and antiparticles. These are so contradictory in nature, that they collided with each other and will be destroyed. This is one of the unsolved problems in physics. We call this Baryon annihilation, matter, antimatter annihilation. If things are going like this way, then the universe we see today would never be formed. But the whole universe is made up of matter, particles. For this to happen, there must be more particles than antiparticles. If the Big Bang took place in a state of equilibrium between space and energy, this state of affairs, Baryon asymmetry, would not have arisen. Let us consider this singularity and its native space as a closed system. In an equilibrium system, particles always form only in pairs. An imbalance in the ratio between energy and space can create an imbalance in the ratio between the formation of particles and antiparticles. But we cannot see this as a large-scale imbalance. In the early universe, the difference between particle pairs and free particles was very small. We can see this difference in the period of origin of the particles after the Big Bang. An independent particle formed only when there about 1 billion pairs of particles were created. Therefore, it can be seen that the difference in the ratio of space to energy in the universe is very small. This difference is the main reason why the Big Bang can happen at that particular time. Now we will check how particles can exhibit both particle and wave properties at the same time. Early we thought that light had only a particle nature. We later learned that light exhibits particle properties as well as wave properties. We proved it through the double-slit experiment. But the problem that bothers me is why light exhibits these two qualities. This will not happen without a fundamental reason. I strongly believe that it is because of the two kinds of motion of light or particles. To learn more about these different types of motion, let us first examine the structure of the solar system in detail. We know that the Sun is the center of the solar system. Planets and other objects in the solar system orbit the Sun. So it can be said that all these are within the spacetime of the Sun. We can take the Sun and the Earth as examples to understand in more detail. The Sun has a spacetime proportional to its mass. According to the general theory of relativity, the Earth is located within the curved spacetime of the Sun. Naturally, the Earth can also create a curved spacetime proportional to its mass. Although the Earth is located within the Sun's spacetime, the Earth is creating its own spacetime over there. Now we can see two different spacetimes within a system. This is how the Moon creates another spacetime within the Earth's spacetime. Although within the spacetime of the Sun, the Earth's spacetime is independent. Earth's spacetime has all the characteristics of the Sun's spacetime. That is why the Moon can create another spacetime within the Earth's spacetime. Now we met three different spacetimes within a single system. Now let us see how they move. As the Earth orbits the Sun, the spacetime with it also accompanies it. Otherwise, the Moon, which is located within Earth's spacetime, could not remain there. Here we can see that spacetime also move according to the motion of the mass. Now let us look at another type of motion. Suppose we are throwing a stone into a pool of water. The stone will sink into the water soon by making waves on the surface of the water. Here we cannot see a motion like the one seen in the solar system. When the stone is submerged in water, it leaves its own spacetime on the surface of the water. That spacetime is added to the Earth's spacetime. Whenever the stone is taken out of the water, the spacetime will be added to it again. If we examine here in detail, there is only time with that stone. Space is added to the Earth's spacetime. It is happening like this because the characteristics of water and spacetime are different. So let us see what happens when an object moves from one spacetime to another with the same properties. For that, we can observe the motion of a photon. Suppose a photon enters the Earth's spacetime from within the Sun's spacetime. That photon is capable of two modes of motion. It can travel through the Earth's spacetime while keeping its spacetime with it. Like the motion of the Moon within the spacetime of Earth. Similarly, a photon can move freely by attaching its space to Earth's spacetime. Later, when it goes beyond Earth's spacetime, it can regain its own spacetime. We can see these two types of movements in the double-slit experiment. While the detector is active, it may add its spacetime to the Earth's spacetime. In all of our motions, we are carrying spacetime with us. Even our spaceships are following this type of motion. So we need to find a way to add the object's spacetime to the parenting spacetime. If we can use this possibility in space travel technology, we will have a revolutionary breakthrough. If we can understand how energy and space interact, that is the key to the mysteries of the universe. Thank you for watching our video.